Hello, these are instructions for the pumpkin pie math lab that we are doing in class. This can be printed off of Schoology, and for those that are absent, I have a specific copy that you can print from your computer that has some of the information you will need filled in. So make sure to print that out first and then work with me through this investigation here. So make sure to put your name at the top, put your class period and the date you are completing this assignment. For this assignment, your objective is to understand the ratio of pi and how it's used in formulas such as circumference of circle, area of a circle, volume of a sphere, and volume of a cylinder. So a couple things before we get started, I wanted to go over these vocabulary words that will come up throughout the investigation. First one is ratio. A ratio is a relationship between two numbers. So for example, 60 miles per 1 hour is a ratio. So is an example like 3 apples to every 1 orange in a bag of fruit. Ratios can also be set up as a fraction. So if you had 1 puppy for every 5 kittens, that would also be a ratio as well. The value of pi is actually a ratio, and we'll get into that in this investigation. So volume is the space inside a 3D shape. So you should be writing these definitions along with me. These are very simplistic definitions, just to give you a reminder of what these words are. Radius is the distance from the center to the outside of the circle, or halfway across the circle. And then circumference. Circumference is the distance around a circle. Diameter is the distance across a circle. And when you find that distance, it has to go through the center of the circle, like that. And then pi. Pi you know as the value of 3.14 and then some more numbers there. It is a ratio of circumference to diameter. So it's a ratio of circumference to diameter. What that means is if you take the circumference of any circle and divide it by the diameter, you'll get this number of pi, 3.14. Or if you take the diameter of a circle and multiply it by 3.14, you will get the circumference of the circle. Okay, formulas to review. These are formulas we've been working with in class, but this is just to review the formulas with you. We have area of a circle, area equals pi r squared. We're going to practice that formula here. So area equals pi, which we'll use 3.14 for our calculations. Radius for the circle is 5, so we'll do 5 squared. To solve this, you need to make sure to do the 5 squared first. So 5 times 5 is 25. 25 times 3.14 comes out to an area of 78.5 centimeters squared. And we'll be using centimeters throughout this entire investigation. Okay, number 2, volume of a cylinder. The equation's right here. Volume equals area of the base times the height. Well, the area of the base is a circle, so that's why we plug in this pi r squared into the equation. To solve this, we do 3.14. The radius of the circle is 5, so we'll do 5 squared. The height of the cylinder is 4. So then I get 3.14. 5 squared is 25 times 4. If you multiply these 3 numbers, you will get 314 centimeters cubed. And the last one, volume of a sphere. Here's the equation here. Volume equals 4/3 pi. We'll use 3.14 again. Radius here is 5, but this time the radius is cubed. 5 cubed, 5 times 5 times 5 is 125. Here's where people often get stuck. They aren't sure how to plug this into a calculator. Well, what you can do is 4 divided by 3 times 3.14 times 125, and that will give you the volume. So volume equals 523.3 repeating, and that would be centimeters cubed. Okay, so now flip to the next page. Okay, so this is structured just like a science experiment where you have the data collection here, and then you take that data and do an analysis. In our case, an analysis is going to be equations where we'll calculate different things with the numbers. And then from there, you'll complete the tables. And then the last step is to do a discussion or conclusions on the data that you found. So starting with the data collection, in class they were given pumpkins, like actual pumpkins to measure. And they measured these in class, but I'm just giving you the measurements here. And you'll use these measurements to do your calculations. So these are all filled in. If this isn't filled in on your paper, just fill these numbers in and then use these numbers for your calculations. So you have radius of the base, which to get the diameter, you multiply by 2. So you would do 14 times 2 to get 28 centimeters here. I filled in circumference of each pumpkin along with the height. And then you'll use these again for your calculations. So 26 centimeters, 16.5 times 2 is 33 centimeters. And 30 centimeters. Okay, so just make sure that's plugged in there. And now we move on to the data analysis. So for this, you're actually going to be retrieving numbers from the data you collected or that I collected for you. Here, I took the diameter of the base, plugged it in here. Circumference of pumpkin number 1 is here. And then I'm plugging it into the equation for pi. So pi is a ratio of circumference to diameter. So I took circumference, divided it by the diameter, and I should get 3.14. Now the thing is, pumpkins aren't perfect spheres or perfect circles. If they were, and if our measurements were exact, this would come out to 3.14. But what I'm trying to show you is that the value of pi can be calculated by taking the circumference of a circle and dividing it by the diameter to get these. So for pumpkin 2, again, you'll just take the number that you have in the first chart. This time the circumference is 98 centimeters. Plug it in and then set it up in the equation 98 centimeters divided by 28. And then for this one we will get 98 divided by 28 and we get 3.5. Which again, as long as it's around 3.14, it could be up to 4 or maybe as low as 2 point something, that is fine. Okay, so you'll continue filling in this chart here, just pulling numbers up here and then calculating just as I showed you. For table 3, we're going to find the area of a circle. So we're taking radius for this equation. So we pulled this number from up there. And then pumpkin number 2 is 14 centimeters. Pumpkin number 3 is 13 centimeters. And you'll take this and plug it into the equation for area of a circle. So area of a circle is 3.14. times the radius squared. When you solve this equation, it's important that you do the exponent first, so 13 times 13, and then times 3.14, and you'll get the area is 530.66 centimeters squared. So you'll fill in the rest of this chart just as I showed you, and then we'll move on to the back, or the next page. And similar process where you take the number from the first table. This pumpkin 1 had a radius of 14 centimeters. Pumpkin 2 had a radius of 14 centimeters. Pumpkin 3 had a radius of 13 centimeters. So then we're going to plug it into the equation for volume of a sphere. Volume equals 4/3 times 3.14 times 13 cubed. And then we'll solve this. So when you solve it, start by doing 13 times 13 times 13, 13 cubed to get 2197. And then I will go through and multiply those numbers. 4 divided by 3 times 3.14 times 2197. And we get a volume of 9,198.11 1 centimeters cubed. Now that seems awfully large. Volume is harder to visualize than length or even area. And of course it's in centimeters, so they're very small little cubes. Then for this, we are calculating the volume of a pumpkin as if they were cylinders. So we're going to take the area of the base, which we already calculated in, it says retrieve from table 3. So if you go back to table 3, you'll have calculated the areas here. So I'm going to take this area of 530.66 and put it here. And then to find the volume as if a pumpkin was a cylinder, we're going to multiply this number by the height of the pumpkin. So pumpkin 3 had a height of 27 centimeters. So 27 centimeters. So to find the volume, I need to multiply the area of the base, 530.66 times 27, and this will give me the volume. Okay. Then you'll continue that here for all of your pumpkins. Just retrieve the area of the base from table 3, retrieve the height from that first table, and then multiply them here to get the volume of a pumpkin as if it was a perfect cylinder. So once you get this filled in here, you'll move to the back and do the discussion and conclusions. And for this, you'll just look at the data and make conclusions. So in table 1, you measured each pumpkin to find circumference. What is another way you could discover the circumference of a pumpkin? Well, you could use the equation. So that might be your answer to number 1. The equation for circumference equals pi times diameter. So you could take the diameter, multiply by 3.14 to get the circumference of any of your pumpkins. Table number 2, what was the value of pi calculated? Would this calculation produce the value of pi for any circle? Yes. If you take the circumference and divide it by a diameter of any circle, provided it's a perfect circle, you will get the value of pi. So just go through each of these. They are a bit subjective, so just put what you think is the best response for this. So go through all of these, and then when you're finished, you are actually going to upload it to Schoology. Upload it to the same assignment you printed this from. It's the Thursday, Friday Pumpkin Pie Math Lab. Take pictures of your work, upload it, and then I will give you credit in Schoology. Have a good day. Bye.